Hello students, welcome to schoolkids.com. Myself Nimmy Wilson and I am dealing with important topics of CBSE Class 10 Chemistry. We have discussed about term to syllabus, the chapter Carbon and its compounds. Today I am going to introduce before you a new topic called isomerism. What is structural isomerism? Structural isomerism is a type of isomerism in which compounds possess similar molecular formula but differ in their structure. We can look at one example. Take an organic compound butane. Butane consists of 4 carbon atoms. How we can write this? We can write these carbon atoms as a carbon skeleton and the valences are being filled by hydrogen. The molecular formula of butane is C4H10. We can also write butane in another formula, that is also fill the remaining valency with hydrogen. We know that carbon is tetravalent, so each carbon must be surrounded by 4 valency. Here carbon has having 3 valency satisfied by 3 bonds. So one more hydrogen is present here. So here also C4H2. So look at these. These both are having similar molecular formula, but they differ in their structure. This type of isomerism is known as structural isomerism. And this is often asked question for examination, that is, write the structural isomerism of any organic compound. Next, we can look at the term hydrocarbon. What is hydrocarbon? Compound containing hydrogen and carbon is known as hydrocarbon. Hydrocarbon fall into 2 categories: saturated hydrocarbon and unsaturated hydrocarbon. From the name itself, it is clear that saturated hydrocarbon means it contains only single bonds, whereas unsaturated hydrocarbon contain double and triple bond. Taking the example of a saturated hydrocarbon is alkane, and example of unsaturated hydrocarbon is alkene and alkyne. Next, we have to look whether carbon is a friendly element. Do you know about carbon? Yes, of course. Carbon is a very friendly element. Why it is called a friendly element? Because it often forms bond with all other heteroatoms. What is called heteroatom? Heteroatom means atoms which is replacing hydrogen in organic compound or a hydrocarbon is known as heteroatoms. Often, atoms to be replaced will be a halogen group, oxygen group, sulfur, nitrogen, etc. These all come under the category of heteroatom. Next important point to be noted is that always while writing a functional group, this sign will be produced, and this is indicating the free valency of the atom. Now we can look at some of the functional groups present. The main functional group of heteroatom present is halogen. It is generally represented by X. This X can be chlorine or bromine. Next heteroatom is oxygen, and this oxygen comes under various categories, that is, it can occur as an alcohol. It contains an OH group. It is called alcohol. It contains a C double bond O. It is called ketone. If it contains a CHO group, it is called an aldehyde. And if it contains a C double Hydrondo-OH is called an acid. So these are the main functional groups of heteroatoms present in organic compound which must be studied for writing an organic compound. Next topic to be discussed is homologous series. Have you heard about the topic homologous series? What do you mean by homologous series? Homologous series means it is a series of a particular type of compound in which the same functional groups are repeated. It is a series in which a same functional group is repeated consecutively. We can take an example. That is, what is the structure of methane? We can take methane and ethane. Methane is denoted by CH4. Ethane is denoted by C2H6. What is the difference between these two? It is differed by a CH2 unit. Next, take the three carbon atom, that is propane. Propane means it is C3H8 and butane C4H10. It also differs by a CH2. So these all comes under the category of homologous series, and this homologous series is known as series of alkanes. That is differ by a CH2 group. This homologous series means here in that series physical properties of the compounds will be different. Chemical properties will be same because same functional group is present. Only their physical properties will be different. Physical properties different means as the molecular mass increases, we know that physical properties occurs retrogradation. That is, as molecular mass increases, boiling point and melting point also increases. So while comparing methane and butane, which will be having higher boiling point and melting point which is having higher molecular mass. But these all possess similar chemical properties because functional group present here is same. So this category is known as alkanes and it is denoted by a general formula CnH2n plus 2. We can verify this, that is we can take n should be 1 to till number of atoms, that is if n is equal to 1, we can look, it will be C, 2n plus 2 means 2 into 1 plus 2, that is 4, CH4. If n equal to 2, C2H6. If n equal to 3, C3H8. If n is equal to 4, C4H10. If n is equal to 5, C5H12. If n is equal to 6, C6H14. And these all comes under the category of alkanes. And the name of this is called methane. This is called ethane. 3 carbon atom is called propane. 4 carbon atom is called butane. 5 carbon atom is called pentane. 6 carbon atom is called hexane. 7 carbon atom is known as heptane. 8 carbon atom is known as octane. And so on. These all come under the category of alkane. Next we can look at an unsaturated series of homologous series, that is alkene. What is an alkene? Alkene means it consists of a double bond. The simplest alkene is ethene, that is CH2 double bond CH2. Is known as ethene. And this is having a general formula of CnH2. We can look at an example, that is if n is equal to 1, it would be what? C. N is equal to 2. N is equal to 1 actually comes from the category of alkyne. So we can start from n is equal to 2. If n is equal to 2, it would be C2, 2 into 4, C2H4, and this is ethene. If n is equal propene. This is called butene. And the 5-membered is called pentene. 6-membered is called hexene. 7-membered is called heptene and so on. Next category is triple bond, that is alkyne. Simplest one is ethyne, that is CH, triple bond CH. And this is having a general formula CnH2n minus 2. That is, if n is equal to 2, it would be C2, then H 2 into 2 minus 2. It's 2 into 4, 4 minus 2, 2. That is C2, H2, that is ethyne. So n is equal to 3, it is C3, H4, that is 3, here we have to do 3 into 2 minus 2, 3 into 2, 6, 6 minus 2, 4. And this is known as 3-membered carbon atom, so it is known as propyne. 4-member, it will be C4, H, 2 into 4, 8, 8 minus 2, 6. So, it is known as butane. 5-member is known as pentyne. 6-member C6, H10. It is known as hexyne. 7-member is known as C6, H10. It is known as hexyne. 7-member is known as heptine and so on. And these all comes under one category because it all differs by the CHU unit. So it all comes under a single homologous series. So I hope you are clear with this homologous series. Now we can look at the nomenclature of organic compound. And this is, since you know that our term 2 examination is subjective type, so often questions will be asked, write the nomenclature of organic compounds. Or sometimes the compound will be given and you have to write the name. Or sometimes name will be given, you have to write the structure. So an important thing to be considered is that you will study how to name an organic compound. And it is known as nomenclature of organic compound. The first thing to be remembered is that we have to add the number of carbon atoms and name accordingly. That if it is having 2 carbon atoms, its name is ethane. If it is having 3 carbon atoms, its name is propane. 4 carbon atom, butane, 5 carbon atom, pentane, and so on. As we studied before. Next thing to be remembered is that some functional groups will be present, or hetero atom will be present in the carbon atom. So, we have to name that functional group by adding prefix or suffix to the name of the organic compound. If the functional group ends with a vowel, that is, functional group ends with a vowel, vowel means A, E, I, O, U, then we have to, suppose we are taking a 3 carbon atom chain. So its name is propane. So if we are using a functional group, that is keton. Keton means its name ends with a vowel. So what we have to do that? We have to remove the last alphabet of the organic compound and add the functional group to it. And the keton, the name of functional group is represented by on. So if a keton group is present in a 3 carbon atom chain, it would be known as propanol. Here, this functional group is added as a suffix, that is one which is in the back side of the organic compound. Sometimes some groups will be added as prefix, that is before. We can take one example, that is we can take a 3 carbon atom chain itself, propane. And we are taking a functional group, that is halogen group, that is chlorine. Here also the functional group ends with a vowel. So you have to remove bromo, we can name it as bromopropane. Here, the functional group is given before the organic compound, so it is known as prefix. And here it is given the back side, so it is known as suffix. Likewise, we can name each and everything. So, we can look at some examples now. We can take the example of a propane group. That is, we are adding this functional group substitution to a propane group. First, we are adding chloro, then bromo, then alcohol, aldehyde, ketone, carboxylic acid, so we can take propane. Propane means it is having a 3 carbon atom. So we are adding chlorine group 2. So 3 carbon atom means this is the structure of propane actually. If one hydrogen is substituted by chlorine, it is known as chloropropane. So we can remove this hydrogen and substitute one chlorine. So it is known as chloropropane. We have to study both the structure and name of the compound. Next we can substitute bromine. That is, again when the carbons collected, fill the valencies and substitute bromine. So it is known as bromopropane. Next is alcohol. So we can draw the carbons collected and substitute hydrogen by OH group, that is the functional group of alcohol. So its name is propanol. That is, this is the functional group of alcohol. Next we can take an aldehyde. We know that we can write this functional group here. It will be easy to understand. Aldehyde group means, okay, we can write the carbons collected, fill the valencies, and here we have to substitute, that is, the aldehyde is propanol. If you name it as propanol, that is aldehyde means it is known as L. If it is propanol, it should contain only 3 carbon atoms. So, in total, since the functional groups contain 1 carbon atom, we have to write the carbons collected here. Then we can write this CH double bond and check whether the valencies are satisfied. Here carbon is having 4 valencies, is satisfied by 1 hydrogen, 1 bond and 2 bond. So this is the structure of propanol. If there is 3 carbon atom present, it is known as propanol. If there is 4 carbon atom present, it is known as butanol. Often this aldehyde would be often mistaken by students, that is, they will first draw 3 carbon atoms and again they will draw another carbon atom. So the idea to be remembered is that while writing aldehyde, total number, if the name is propane, total number must be equal to 3, including the aldehyde group. Okay. Next we can look at the ketone. Ketone means this C double bond. So we can write carbon chain like this, and this is substituted by a ketonic group. So we can look whether the valence is satisfied. If this carbon is satisfied by 1, 2, 3. So we can write 1 more hydrogen. This is known as propanol. Next is carboxylic acid, and its group is C double bond OH. And we are taking propane. Then this carbon is having 4 valency and is satisfied by 2 here and 2 here. So valency is satisfied, and this is known as propanoic acid. So here only this chloro and bromo group is having a prefix. Other all functional group is having the suffix here. So this is an important topic which should be asked for your turn to subjective exam, that is either they will ask write the structure of chloropropane or chlorobutane, or they will ask write the structure of propanol or propanol. So while considering the functional group with carbon atom, one thing is to be remembered is that in total there should be, if propanol is taking, there should be 3 carbon atoms in total. So this is about the nomenclature. I hope you all are clear with the topics discussed today. Since this is organic chemistry, you have to practice it thoroughly, then only you will be able to understand what I have taught. So if you have any doubt, please feel free to mention me in the comment section. Thanks for watching. Thanks dear students.